Now let's have little bit of knowledge dissemination session. And on this note, I would like to call upon stage Shankkar Narayann in the capacity of Strategic Business Unit Head and also spanning 22 years in this particular domain, and he has worked in the strategic planning, sales, marketing, business development.
Good morning, everyone. I'm Shankkar from Elsevier. Elsevier was founded in 2011 for a single objective: to be a leading solution provider dedicated to greener and sustainable future. I would like to share something which I learned during early days of my career. I realized that doctors are not aware about medicines. They understand the symptoms, they are able to diagnose diseases, they understand the affliction. It is the industry who tells them that if you see such and such symptoms, these are the medicines to heal. The people, the ecosystem is suffering from the pandemic of pollution. We as Elsevier are dedicated in this mission to give mankind quality of air to breathe. Conditioned air is not a luxury anymore. It has become an integral necessity of the urban population. Elsevier has got a lot of value-added solutions when it comes to indoor air quality. We provide UV-based germicidal irradiation. We provide PCOs and PHI cells. We help in VOC removal from commercial kitchens as well as industrial pollution. Elsevier provides various water-based solutions. We are passionate about conserving water, which is a depleting resource, and we provide customized pumping and filtration solutions to address this concern. Rapid urbanization has led to a requirement of air-conditioned environment and growth in cooling demand. Mostly I'll be repeating what Mr. Hanif expressed out here. But yes, I would like to stress on that residential and commercial and industrial buildings account for 40% of peak electricity demand. This is a very conservative estimate, mind you. Because the temperatures are rising and commercial cooling systems is becoming a must-have, this trend is going to increase. The world needs clean energy storage to power commercial cooling systems with renewables. Commercial air conditioning demand in India. This was presented earlier in ACREX by one of my colleagues. And the data stands true. So we are looking at somewhere around 40 million TR at present to exceeding 130 million TR of installations. Cooling demand in India is projected to grow 18 times by 2050. Cooling contributes to 40 to 60% of this demand. And this is something I believe we as a whole, as stakeholders, need to address in energy efficiency. Elsevier's sustainable solutions reduces a building's carbon footprint and enables flexible demand while also cutting energy costs. We need to transform building into energy assets. Energy efficiency in cooling do not only bring financial returns to the users, but it also creates benefits in terms of lower greenhouse emissions, reduced carbon footprint, and promote sustainable developments. By embracing water-based energy storage, commercial buildings can shift their energy demand, save energy costs, accelerate renewable integration, and contribute to fighting climate change. Water is a fascinating substance with the highest capacity of storing energy. It is safe, and its ability to store energy has endless cycles. It never degrades. There aren't any substances that are safer or cleaner. It's obviously a no-brainer. It's the obvious choice. Thermal energy storage is a direct contributor in achieving your sustainable goals and is an integral part of global sustainability, carbon reduction budget, and objectives. We harness the power of renewables to meet commercial energy consumption. Key benefits of thermal energy storage: HVAC installation downsizing and thus saving capex. Chillers, cooling towers, pumps, etc. You can downsize up to 70%. Electrical demand charge reduction up to 70%, and reduction in backup generators up to 50%. Thermal energy storage also contributes in optimizing your OPEX. Chillers can be stopped during electricity outage on peak periods to optimize operation costs. A maximum cooling, reduced cooling capacity during electricity on peak periods. A free backup cooling capacity during predetermined period. Reduction in diesel costs in up to 50%. Thermal energy storage contributes heavily when it comes to the environmental impact. You have a possibility of renewable integration. It contributes in CO2 reduction. It reduces heat island phenomena. I think this is something that we can see in Gurgaon, our dense urban population assets, I'll say, construction assets. For building owners, you have cost savings. We are heading towards EV, and this gives the building owners to charge more EVs. It provides a backup and resilience. And of course, it contributes towards a greener building. Towards the utility grid, it increases grid reliability. It provides resource adequacy. You have to build less transmission and distribution. You have to build less power plants. When combined with clean energy like solar, thermal energy storage reduces grid dependency, and it helps in stability of the grid as peak requirement can be catered through TES. As per the latest budget announcement, TES, and obviously this falls under the infrastructure category and comes with the benefit of reduced taxation on capital investment and also 100% depreciation benefit. Enseavia accelerates this growth of a renewable energy revolution with its sustainable energy solution. We turn commercial building cooling systems from grid burdens to clean, safe, and cost-effective energy storage assets. Here, we as industry professionals, I believe it is our moral responsibility to educate and implement sustainable solutions which can improve quality of life and the ecosystem in an energy efficient way. We seek support of all the stakeholders in optimizing energy transition, decarbonize existing assets, save our natural resources, and build a greener future together. The time has arrived for buildings to stop being part of a climate emergency and start being part of the solution. We are in the midst of an environmental revolution, and we have a once-in-a-lifetime opportunity to stand up and change the future in a meaningful way. I believe now is our chance to act, and now is our chance to make a difference. The future is bright, but we have to do something for it. We have a responsibility to wake up and act, and that's why making the switch to clean energy solution will not only reduce a building's carbon footprint, but it will create a future that we can all be proud of. Thank you so much. Since we are talking about residential, the topic is residential buildings. I did a quick analysis of a residential building project. Here I have compared with Split, where we and we can see the chilled water system with thermal energy storage. It cuts down on your capital investment as well. There is a 44% size reduction. There is no reduction in cooling. There is no difference in comfort. The challenge what we all face when it comes to residential buildings and implementing a centralized cooling system is the developer, once he sells off this asset, he has no control. But here I would require support of professionals. We have service integrators like JLL, Cushman Wakefield, Embassy, and I believe working with these system integrators, we can actually reduce the installation base of air conditioning units, individual units, and having a centralized consolidated system will definitely improve or highly reduce your CO2 emissions. There is a lot of other benefits also. I stay in a complex which has got 800 flats. Each flat has got minimum 8 HP to it exceeds to 17 HP. There is an outdoor unit and lots of indoor units. But when it look at the diversity factor, the usage of these installed units, I'll say when it comes to usability, it's only less than 40%. Not only that, we have refrigerant out here. Having a centralized system is going to drastically cut down on the investment part and severely contribute on CO2 reduction because of OPEX reduction. Please, actually now I have to show a video. I'm done, so I just wanted to show this case study. Please do. Please do.
So, you're paying the level that advocate.
Yeah.
If you talk to VRV manufacturer,
Yes.
they talk of POP that's very low.
Absolutely.
And if you are an intelligent
designer or an intelligent system integrator, probably what you will do is to select a COP. You know, some VRV manufacturers claim that at 50% load, the COPs are as high as 7.1, right?
Yeah.
And if you are an intelligent designer or intelligent installer,
yeah,
you will select equipment based on, you know, the loading patterns. Like for a commercial building, you would say that for at 50% of that, at 75% of the time, 50% is the load.
Yeah.
So if you select a COP like that and design your whole system, you know, studies have shown, you know, and I have a case study which shows that, you know, you can achieve a COP up to 5.97. That's a calculation, right? And maybe that can be questioned by a lot of pundits and all the consultants who are sitting here. But then, you know, I'm just playing a devil's advocate to what you're saying there, you know, that you're 44% cheaper. I just now have a study will show you where I've calculated for a commercial building, I installed about 4,007 buildings because water was a constraint there.
Yeah.
And as you rightly said that, you know, water is going to be a problem. So, you know, the COP worked out as about 5.97. So what would you have to say on that?
One, I didn't say it will be 44% cheaper. I said the installation base gets reduced by 45%. One thing what I would look at is, yes, you are right in your sense. It's all about the industry designers. You have there is no standard thumb rule that you can implement. Okay, that this is going to work or this is not going to work. Yes, obviously, when you have a centralized system, your capex is going to come down. OPEX is better because here you are. Why I'm saying this is you don't have any refrigerant in the circuit. Connected, your infra demand from the grid comes down. So that's what I'm looking at when you have a I'll say a district cooling or that kind of setup rather than individual setups. If you have a centralized system, it becomes easier in operation. It's modular to expand, to update, and not only that, water is safe as compared to still refrigerants. I'll put it that way. But yes, but it will definitely come down or reduce your grid dependency. Particularly, I see outages, and during outages, what you have diesel running. So this takes care of all these concerns, which you cannot do with an individual setup of a VRV, even though you have the best COP. Are there any other questions? Yes, sir.
VRV is a good choice. Secondly, if we are talking about water scarcity, in a residential sector, water scarcity is not there. Because if you have a treatment plant, which is mandatory, then you have at least 135, we consume much more, as Saurabh was trying to tell us. And that is a fact. With servants, we are consuming to 200 liters, 250 liters. We had a conference with IIT where we were grilled when we were putting in MBC 135 liters per head. They said no, it is useless. Not more than 80 is consumed. But in actual finding, it is more than 200 liters, which we consume. Now, if you have that much of water, what is your air conditioning? And secondly, what you said is we are the oversizing by VRV gives you diversity benefit.
Absolutely.
And then you can have VRV water cooled.
Yes, sir.
So there is no question of heating metering,
Yes.
which is also solved. You have a water cooled VRV. There is no question of reducing that or putting the external somewhere
Right.
and reducing that to this.
Right.
So all these factors, if you look into a broader way,
Yeah.
we can find a solution.
Absolutely.
But it's a joint work.
See, I absolutely agree, and this is what I say. You cannot have one rule applicable in each and every segment. It is optimization, and this is where all the professionals out here come into the picture. So yes, in some cases it will work. Some cases we will be better. So we have to look at holistically at this approach. So, absolutely. Say take for Chennai for example, you have severe water scarcity. Okay, so people are shifting from water cool to air cool. So absolutely.
Geographical zone matters much more.
Yeah.
Because if you look into Bangalore and you insulate your building, a residential building, you lose.
Yeah.
You lose by spending more energy, consuming more energy. Whereas now today, of course, the scenes are changing because we have a lot more to add on because of our own creation. But otherwise, 10 years back, Bangalore didn't need any air conditioning.
Absolutely.
And if you could make a thin building without thermal mass, that was the best solution for residential. Because there is no thermal lag, there is no depression. So you are equating with outside temperature and natural ventilation, which is the best solution.
If you had seen my slides, I've spoken about the heat island phenomena. So, see, the few construction that's happening where you have space to design, you do that. But I'll say in the past 10 years, the kind of urbanization, it was rapid. It was just whatever space you have, you just build it, sell it up, and try to make money out of it. So it was there was no holistic energy efficiency or an holistic consideration for it. And in terms of urban population, yes, we need to work jointly and look at the correct solution and pitch the correct solution.
You have any success stories for your thermal energy storage? Any of your residential plants or residential buildings?
Unfortunately, see, the residential project we were talking about, what happened, like I told you, the hardship or the constraint is the developer hands it over. So then the RWA is the decision maker. Now, when we talk about these models, we talk about ESCO model, okay, meaning utility, energy as a utility and with a BTU meter utility billing. But tomorrow, if the RWA changes, then the people who have installed the equipment or operating the equipment, they stand at a risk, okay, if they don't agree to the cost or whatever, X, Y, Z reasons. So that is a constraint. So as long as either the developer has control of the assets or you have a single body who is facilitating the services. Like I said, service integrators like Embassy or JLL, CNW and all that. So they can, then you can have a centralized system approach. Otherwise, it becomes a challenge. But yes. Thermal energy storage, yes, but not in residential. In commercial, very much, sir. We installed at a mall in Chennai, and we are saving some. We installed it 3,000 TRS, and that was with ice. And we are saving somewhere around 60 to 70 lakhs every year. That's an air-cooled chiller, brine chiller. In terms of 60 lakhs saving as against, okay, I'll put it this way, every year they were spending an additional 60 lakhs. So we have, after installing storage, they are saving 60 lakhs every year. It was somewhere around 2.2 total. It's one of the biggest malls in Chennai. We also installed in an industry in Siemens. We also, and everybody most likely should be aware about the GIFT City installation of thermal energy storage, which is massive. That's a district cooling. And GIFT City, if you, one of my colleagues, Gaurang, he has prepared an article also, and you can see the initial plan for the whole facility was somewhere around 240 megawatt. But with thermal energy storage, it has come down to 130 megawatt. So there is a huge reduction in capex itself because you have a centralized system. So this is what I'm proposing. Energy transition is something that thermal energy storage helps. Optimizing, or rather the leakages, the losses, or the unused capacity. And it helps in way, like if you have solar, I've been to plants. To another question, we have installed in industries also, we have installed in commercial spaces also, in offices also. And yes, it depends on application to application. There is no standard rule. Everywhere you have different reasons. Siemens installed because they have diesel issues, power cuts. So to replace that, they had to, or rather to optimize that, they had to install storage. There is Chennai Mall installed because water was a scarcity, and they had to shift to air-cooled chillers. And daytime, you know, Chennai weather, the amount of power that is going to consume. So they shifted their load to the night time. So there is a misconception that if you have differential tariff, then only it works. But I beg to differ. Differential tariff is a bonus. And here we are talking about a life cycle of an equipment that is 25-30 years. Yeah. Thank you so much, sir. Thank you.